Good afternoon, everyone. My name is Mahesh Kumar. I'm the Chief Marketing Officer at Acceldata. Rohit Chowdhury, our CEO, couldn't be here due to some unforeseen circumstances, so I'm filling in for him. The AI age is well and truly upon us. If you think about the explosion of action that's happened in the last 2 years, people are desperate to stay ahead of the game in AI. Yet, underneath all, there is that little bit of that trepidation and uncertainty. Are we doing the right things? Am I building the right models? Are they working together? You have agentic frameworks now, one model feeding another to do more complex tasks. Are we using the right models? Are we using the right LLM? Do I have the right features? Those are all great concerns. So when we think about how do we succeed in this era, I posit there is a much more fundamental, basic Occam's razor kind of a concept at play here. What's missing really is trust in the data. This is actually fundamental to everything. I'm not saying those other decisions are unimportant. They are absolutely critical. But if you don't trust the data, it's very hard to make progress in AI. Look at some of these examples. If an AI model fails, this is a telco company, if their model drifts and this is a positive feedback loop within 24 hours, they know their model has drifted because they used to get X amount of fulfillment previously. It's dipped 2 basis points. The escalation goes straight to the CEO because it's money in the bank that they are not having. The challenges that data engineering teams have today are multiplying. Most of their time is spent on bits and bytes of basic infrastructure, day-to-day blocking and tackling. That makes it harder for them to actually deliver better data products. I just want to confirm, is there an audio issue here, or can you all hear me well, or is it going up and down? Is it OK? All right, thank you. So when you look at all that, what's the role of data observability? Why does it assume such great importance in today's AI era? That's a question I'm sure that's on your mind. Before I get into the details of data observability, I want to compare and contrast a little bit between some of the other systems that you use. Let's start with data governance. The typical amount of data that's in that is in the order of gigabytes in most enterprises. It varies sometimes from one enterprise to the other, but you're really talking about order of magnitude estimate. And the change frequency is about a month. You don't change your governance policies every time. It happens once in a while. But you have to obviously measure your compliance or controls against those governance policies all the time. Likewise for data catalogs. The frequency of change is a little bit more often, weekly perhaps. And the volumes of data that is in those systems, metadata and everything else, is on the order of gigabytes. It's not more than that. You compare and contrast that with data observability systems. You're talking about processing millions and millions of rows of data on a daily basis. Multiple hundreds of gigabytes, terabytes, in some cases, very rare cases, of course, petabytes of data. The scale with which you have to do that and the time frame you have to do that is fundamentally different. If you have to redo your offer models, you're a retail business, you have to redo your models every day, you have to have good data passing through your systems, the latest data, fresh data passing through your systems, and those models being built within that 24-hour cycle time. So all the processing that you have to do on your data has to happen in a very short period of time. This is one of those capabilities that data observability offers, is processing a lot of information at scale in a short period of time, very specific to your business, right? What does it entail? What are the various elements of data observability, you might ask? So keep the scale in mind, because later on we're going to get into a couple of examples of customers who are building AI models and what they saw, why those models failed occasionally, and what spurred them to get into data observability and be successful through that process. Gartner defines data observability as consisting of 5 pillars. First is the data itself. A very important piece, of course. When we're talking about data, you can't ignore that. Is the data reliable? Is it of good quality? Is it fresh? Is it drifting? Is it reconciling from system to system? Very important situation for us to actually keep in mind. The second piece is the data flow and the pipelines on which it's running on. Are the pipelines healthy? Is my Kafka topic feeding my data, with the right sort of throughput? Am I lagging? Things of that nature. You have to be able to observe that. Third is infrastructure that's running on. Do I have enough capacity? Every Monday, I get people downloading reports, thousands and thousands of reports, and it's a weekly report. So everybody comes in Monday morning. I know in that 3-hour period of time, all my weekly reports are getting downloaded by my business users. Is my infrastructure capable of handling it? Is it scaling up and down? If there is an issue, can I make a change and free that bottleneck? Cost is a very important consideration. If you look at data clouds like Snowflake, Databricks, AWS, GCP, Azure, pick one. It costs money. You run a bad query without somebody's knowledge, and it keeps running for, say, a week. Nobody noticed. A stuck query. It's consuming credits, and you're paying for it. These cost surprises shouldn't hit you. That's the third aspect of it, a fourth aspect of it. And finally, the users. And there are several types of users. You have the business users who are actually accessing reports and such. You have the users in the data team who are writing queries and helping keeping your infrastructure up to date and functioning well. So there are different types of users. And so you have to understand their activity and who's doing what in order to make better decisions in terms of your data infrastructure and how you observe your data. What do you have to look for when you observe your data, and so on and so forth. These might look a little disjointed, but they are very interconnected. Let me tell you why. If I get a huge amount of data dumped today, an unexpected volume of data, which gets pushed through the pipeline, it affects the capacity of my infrastructure to be able to handle it. It delays my pipelines potentially. It delays my reports. As a result, the users get affected by it. If a business analyst or any other person writes a bad query, it suddenly increases my infrastructure cost, my spend. In 2 weeks, unbeknownst to me, I would have spent almost a month's worth of credit on just 2 queries that were like really, really bad queries. So like that, these factors are completely interconnected. We cannot separate one from the other because one affects the other in various different situations. And we'll go through those, couple of those down the line here. Where does data observability actually fit in? You have on your left a lot of your data sources. You're ingesting data from so many different sources. And then on your right are your consumption points. It goes into your AI ML models, number one topic that we are here to talk about a little bit more. Various data products, analytics products, and so on and so forth. In between that, those two endpoints is your data pipeline that transforms your raw data into a finished state that can be consumed by your end users. Data observability essentially fits into and monitors the end-to-end process, from where the data lands all the way to the consumption point. And it monitors that for various aspects. Chief among them being quality is very important. Is the data of good quality? I'm not talking about is the rain checks correct, or is it the right format, things of that nature. When we talk about quality, you're really talking about next level in terms of, does that data fit and model the business policies that I have in place? If I have a column for revenue, it should always be above 0, right? That's a business policy. I need to be able to reconcile my orders with my delivery and payment systems. That's a reconciliation use case where you want to reconcile data from system 1 to 2 to 3, because you don't want to make payments to the wrong people, or you don't want to be delayed in making payments. It's amazing how many corporations and companies have these challenges every day. Data freshness is very important. And we'll get to that in a very interesting analytics use case that one of our customers had. Speaking of customers, I'm going to digress here a little bit more generically to speak for a minute about Acceldata, and then we get back into some specific examples and why data observability helps in the AI/ML situation. Acceldata has customers across all industry verticals. We typically work with enterprise customers, mid-enterprise to large enterprise. The critical point is to understand, when you're doing data observability, you have to be able to observe your on-premises systems and cloud systems. Very often, especially in enterprise customers, a lot of the data pipeline processing has been built over years, and you just can't extract everything and put everything in cloud on day one. Frankly, a lot of it's never going to go to cloud, because it's so intricately integrated with a lot of their suppliers, distributors, and external third parties and everything else. So to make a shift like that is a big, humongous effort. So you always have to assume that observability has to span both your on-prem infrastructure and your cloud infrastructure. Typically, customers push some of that processing to the cloud, going into Snowflake as a data warehouse so that business analysts can use Tableau, Power BI, and other things to actually produce those reports. So observability has to be able to span both on-prem and cloud, and that's what we actually support. And operating at scale. If you're a financial institution or any healthcare, retail, the transaction volume and things of that nature are very, very significant. You're talking about millions of rows of data every day that are getting generated and pushed through your pipelines. So you have to be able to support all the rules and policies at tremendous amount of scale. I'm going to take a couple of minutes now to walk through some use cases. This is a top 3 bank, and they make credit card offers. Obviously, you want to make the right offer to the right person at the right time, which means ingesting a whole bunch of data from various data sources, passing it through your data pipelines, building a model, and making predictions on which offer to offer, to give to which customer. In a lot of these scenarios, you find that there is some impetus to making a change from where they were today. If they had a data quality system, a traditional data quality system, they are sampling the data because they can't scale, or applying just a few checks, basic checks like formats, ranges, things of that nature. They basically hit a situation or scenarios where they essentially reach the conclusion that my models cannot sustain based on my current set of processes. And they essentially say, I need a scalable solution that works end-to-end in my enterprise. Here's an example of that. This customer noticed that the pipelines that were supplying credit scores was broken. And they did not notice that for a fairly considerable period of time. Now you can imagine building ML models and predicting credit card offers based on outdated credit scores that never got updated for months in some cases, okay? An egregious violation, but it happens sometimes. There is just so much happening. It's very hard to keep track of everything else. So that was sort of their impetus. They said, this is not sustainable. We can't operate like this. We went in, worked with them. They were able to monitor, of course, for things like credit pipeline failures and such. But in addition, they were able to monitor more number of assets than they were before. Because as I said, you're sampling. You're saying, OK, let me monitor this endpoint because I don't have the resources to monitor all the various hops in my pipeline. So they kind of pick and choose where they want to monitor. So a lot of those compromises were being made. They kind of got rid of all of that, reduces the time to repair by 50%, and far fewer SLA breaches. More importantly, I'd say their AI ML models that they built in order to make the predictions on credit card offers were much better now, and they felt a lot better about what they were doing. And there is certainly a huge financial payout because of that, because they had much more accurate predictions. This also goes back to the other first case. In the very first slide I shared, that telco use case where they're trying to give offers to various customers, and small change gets noticed right away. Yeah? So this is a very important use case, just in terms of being able to understand where your pipelines are failing, what's happening in your infrastructure, so that you can immediately correct it and not have a problem sustained for a period of time and have end users and others complain about it, or your business users complain about it. The second situation is a packaged goods manufacturer. They are present in pretty much any retail store that you would go to in the world. I mean, I don't think there is an exception. What's their situation? They had a problem where their sales recommendation engine that they had built, a very complex machine learning model using all your latest AI techniques and everything else, was not giving them the right recommendations. Their salespeople would go to their wholesalers or whoever they are assigned to and make recommendations saying, hey, you need to be thinking of buying this much of this product and this and that. And they'll go, well, I got a lot of stock of this product. Why are you making that recommendation? Or sometimes the recommendation arrives 3-4 weeks after a shelf out of stock happened. So they were out of stock in their shelf, but it hadn't been fulfilled. And they're late to making the recommendation. That's literally money walking out the door because somebody else chose a different product. You want a bar of chocolate, they're going to go grab something else if that's not available. So they had those kinds of situations, brought us in, and here is the situation, right? They are able to deliver 50,000 reports across 87 different markets, geos, segments, all of that. Why 50,000? They have that many salespeople and others all over the world. Different salespeople for different market segments and so on. So very strong, huge sales organization. And this is also a company where on a Monday morning, every salesperson is hitting that repository for the reports. They want those reports fresh, and there is a huge spike. This kind of tying that whole infrastructure observability piece of it, in terms of being able to deliver reliable reports and other things. And these reports contain your recommendations, which are all based on AI, right? They increase their freshness and quality quite significantly and cut down on missing reports. 2,000 policies validated every day across millions of rows. This is a type of scale that you can never hope to achieve with a traditional data quality system or even a homegrown system. There's some uniqueness about the architecture and how you build these things that they're able to scale and accommodate new business models and business policies. The other big advantage of an observability product is you are able to bring the business much closer to the data teams. Typically, a business, if the 2001 policy, let's assume the business has one more policy they want to apply. It typically goes in as a ticket and a request to a data engineer who then has to, through their day, managing the infrastructure, looking at all the escalations and everything else, have to eventually find time to satisfy this request. And a lot of times these things get postponed, and that's one of the reasons why data products are more delayed these days than before, because the teams are not able to respond in time. With observability products, you have a very easy way for businesses to actually add the rules. There is a no-code interface. You can say, hey, I want to add this rule that says this plus this should always be less than this other column over here. Very simple rule. If it violates that, I want you to notify me because there is a problem. Yeah? Those kinds of rules they're able to add. And recently, with the advent of AI and LLMs and everything, we've added capabilities where you can speak these rules in a natural language. You don't even have to access the interface. You just have to speak the policy in a natural language. The system interprets it, creates the right SQL, and then applies it, and then alerts you as and when the policies deviate, right? So these are very interesting. This is the other reverse case of applying AI in order to get better data observability and make it better for you in terms of your data infrastructure. These examples here for these customer situations are really using data observability for AI. But what's happened is, we are able to actually use AI to improve your data observability and get better at it. And because the system can scale, you don't have to think too much about, should I apply this rule? Is it going to be able to handle it, et cetera, right? Because you want to give the businesses the freedom to actually start to use that. The last point I want to leave you with is observability issues can happen anywhere in your infrastructure. It's not limited to your landing point or your consumption point. There are various aspects to it. So a broad-based observability solution should be able to handle all of these things. As well as you get better data quality for your AI initiatives for sure. You get better models, the outcome that you had at the credit card offers and such. Responsiveness to business needs, we talked about that. And data engineers and ML engineers can be much more productive. Imagine if you can actually trust the data because it has passed all the business policies that you think it must pass. That builds trust in data. That builds trust in your AI models. That allows you to build these much more complex agentic workflows because instead of building systems of record, you are now building systems of trust. And that trust is visible for everyone. If I'm dependent on a model, I know exactly what is the quality score, how reliable is it, how fresh is it, et cetera, et cetera. So I can then make those business decisions in terms of relying on those models. So this concept of observability and using it in all of your AI models is very critical because you're starting to build very intricate systems of AI models which serve a much higher business goal or a business purpose. Before I close and take some questions from you all, couple of things. There is a very interesting white paper that we wrote, which is on how different large language models affect your data observability strategy. It's a very good read for you. I would encourage you to download that ebook. I also want you to please visit our booth. We are in booth number 624. It's on the other side of the exhibit floor here. We are there to give you demos. Every half an hour we are doing demos. You can get a brief demo of the product. If it interests you more, we'll give you a deeper dive demo either there on the floor, or we can schedule one later down the road, when you get back to your office and you speak to your colleagues and everything else. Read the Gartner reports. Gartner recently came out with a market guide for data observability. We right now have about 5 or 6 good, strong analyst firms covering this space. This space has been in existence for 6+ years. It's not a new space by any means. But really, with the advent of AI and the desire and the need to build strong, trusted models, there is a resurgence of interest in this. There is a lot of business reasons why you need observability in your data landscape. So there is a huge surge of interest. Educate yourself. You can go download those Gartner reports from our website. It's obviously free. Just give your name and email and whatnot, and you'll be able to read that. So you understand how Gartner thinks about it, how some of these other analyst firms are looking at this space. And educate yourself, and we'll be happy to show you a demo and see how it best addresses some of our business use cases. With that, I'm going to pause, take any questions from the audience, and then go from there.